Let's take a look at the metric system. This is an international system of units, or SI system, that is used to measure specific properties like length, mass, time, and so on. There are really 7 classic properties that are used to be measured with the metric system, and you should be theoretically familiar with most of these. In this course, we will spend time using 5 of these specific properties, where in additional chemistry classes you may add to that. The property measured has a base unit or name of a unit that is used for that particular property. For length, we use the meter. For mass, we actually use the base unit of kilogram. Time is in seconds, temperature in Kelvin, and amount of substance is using the mole. An interesting fact about the mass property is the SI unit is actually the kilogram, and it turns out that the kilogram is based off an alloy between iridium and platinum that was made in the 1800s. And the cylinder is actually a replica of the original cylinder that is housed in France. This cylinder was thought by many scientists as not a very good way to measure a unit of mass. And about a year and a half ago, the National Institutes of Standards and Technology spearheaded a consensus between scientists to actually get rid of using the cylinder as a base for the kilogram mass, and instead move to using a constant value called Planck's constant, which indirectly measures a kilogram in conjunction with the speed of light. When it comes to the metric system, we can actually use prefixes to denote how much you have of a particular amount of base unit. And the really important thing about the metric system to know is that it is based on the power of 10, where when you are at the base unit here, it turns out that you can take that base unit and multiply it times 10 or divide it by 10 in order to create a new value with a prefix. So if I were to take 1 meter and then divide that into 10 pieces, at that point, each one of those pieces, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of these is then considered, the next prefix down, a decimeter. So you can put 10 decimeters in 1 meter. Typically, we write the unit for the use of a prefix in the base unit as the first letter of the prefix and the first letter of the base unit. So for short, a decimeter is actually written as lowercase d, lowercase m. For all of the base units, prefixes that are below the base unit in this diagram, the first letter within that particular prefix is utilized as the symbol, except for micro. Because there's already an M for milli, we use the Greek symbol mu. For prefixes that are above the base unit in this diagram, typically, more often than not, we use capital letters, like for mega, giga, and tera. However, for kilo, we still use small letters. Hecto, we still use small letters. And the convention for deca is lowercase d, lowercase a. However, I have seen a capital D used for deca. It may be important for you guys to go back and look through the powers or conventional notation of how the value of one particular prefix of a base unit is compared to the base unit. And it might also be important for you to be able to translate those conventional notations into exponential or scientific notations. Trust me, they will be useful later on when we're going through dimensional analysis. That's it on the metric system, and we'll hit that in class a little later on. And if you have any questions, don't hesitate to put those in the comments or bring those to class next time we meet.